Properties of alkali metals. Today we are going to complete the chemical properties of alkali metals. At the last session, we stopped at the formation of metal hydride, and we said that metal hydrides are ionic compounds. Today we are going to complete the chemical properties of alkali metals. Open your student book, page 93. The first reaction is lithium hydride reaction with water forming lithium hydroxide and hydrogen gas. So metal hydride releases hydrogen gas. So metal hydride is considered as strong reducing agent. All alkali metal hydrides are strong reducing agents, as they can dissolve in water and gives hydrogen gas. To balance this equation, we can count the atoms on the left side and on the right side. Here we have one lithium. Here we have one lithium. Here we have 3 hydrogen. Here we have 3 hydrogen atoms. Here we have one O. Here we have one O. So this equation is balanced. Now let's move to the second equation. The reaction between alkali metals and halogens. The first reaction, sodium and chlorine forms sodium chloride. This reaction is a vigorous reaction. Another equation, potassium metal reacts with bromine to form potassium bromide. And this is also a vigorous reaction. Now let's balance these equations. Here we have 2 chlorine, so we must put here 2. This 2, as we said before, will be distributed to sodium and to chlorine. So we have 2 sodium on the right side, so we must have 2 sodium on the left side. Let's move to the second equation. 2 bromine, 2 bromine. 2 potassium, 2 potassium. So these are some reactions with halogens. Now let's move to the next point. The reaction with other nonmetals. Reaction with other nonmetals. For example, sodium reacts with sulfur by heating. This gives sodium sulfide. To balance this equation, we put here 2. Potassium and phosphorus by heating, it forms potassium phosphide. And these are solid materials. Potassium phosphide and sodium sulfide are solid materials in normal temperature. Now, these are some vigorous reactions between alkali metals and other nonmetals rather than halogens. Now, let's move to the next equation. What's the effect of heat on the oxygenated salts? What's the effect of heat on the oxygenated salts of alkali metals? At the beginning, What's the effect of heat on metal carbonate? All alkali metal carbonates can't decompose by heat except lithium carbonate. Lithium carbonate is the only alkali metal carbonate salt that can decompose by heat, but on a very high temperature, which is about 1000 degrees. So lithium carbonate only decomposes by heat, but other metal carbonates can decompose by heat. So metal carbonates can't decompose thermally except this equation: lithium carbonate by 1000 degrees, it forms lithium oxide and carbon dioxide gas. Now, other oxygenated salts like nitrates. What happens for nitrates? Nitrates can decompose partially into metal nitrite and oxygen gas. So nitrates forms on heating metal nitrite and oxygen gas evolves. For example, sodium nitrate by heating changes to sodium nitrite and oxygen gas evolves. This decomposition reaction occurs partially. This means that some molecules of sodium nitrate decompose and other molecules will not be decomposed. Now let's balance this equation. Here we have 4 oxygen atoms, but here we have 3 oxygen atoms. So we have an even number on the product side, but we have an odd number on the reactant side. So to get rid of this problem, we must multiply by 2. If we put 2 here, so we have 2 Na, 2 Na, 2 nitrogen, 2 nitrogen. 2 times 3 gives 6 oxygen atoms. 2 times 2, 4, and 2 will be 6 oxygen atoms. So this is a balanced equation. There is an important fact here we must know about metal nitrates. Potassium nitrate is used for manufacture of bombs because it explodes on heating, while sodium nitrate is a deliquescent substance. Deliquescent means it absorbs water vapor and can be used for bombs. So sodium nitrate is called a deliquescent substance, which means it absorbs water vapor and can't be exploded. Now, how can we extract alkali metals? To extract alkali metals, we can't use the ordinary methods. We can use electrolysis. How can we extract alkali metals? Now, let's see. extraction of alkali metals. As you know, alkali metals are existing as ionic compounds. So there are strong bonds between the alkali metal ions and the other ions. So they can't be extracted by thermal decomposition or the simple ways. So we use electricity for this purpose. We can use electrolysis for this purpose. How can we get sodium metal? We can get, for example, sodium metal from its molten solution electrolysis, molten material electrolysis. If we have molten sodium chloride, we can get sodium. We can use this system. By using this system, anode, cathode are dipped inside molten alkali metal halide. Molten alkali metal halide. Example, NaCl in liquid state. And we use flux substance to decrease the melting point of metal halides. We always use flux substance, which is a substance used to decrease the melting point, to lower the energy used. Now, if we have molten alkali metal halide and we have this system, we can get the alkali metal. By applying the electricity, what will happen? Positive ions will move to the cathode. Cathode is the negative electrode in electrolysis. So, positive ions like Na positive ions will move towards cathode. So, at cathode, Na positive takes an electron and changes to Na. This happens at the anode, at the cathode. At the cathode, this equation occurs. This equation is called reduction because it's gaining of electrons. But what happened at the anode? At anode, oxidation process occurs. At anode, oxidation process occurs, which means losing of electrons. So, negative chloride ions, 2Cl negative ions, will be oxidized into chlorine gas and 2 electrons. So, we must here have 2 electrons, 2 Na positive, 2 electrons gives 2 sodium. 2 chloride negative gives chlorine gas molecule and 2 electrons. This is what happens at anode. Anode is the electrode at which oxidation takes place. Oxidation means losing of electrons. Cathode is the electrode at which reduction takes place. Here, gaining electrons is called reduction. So we can get the alkali metal that we need at the cathode. Thanks for good listening and see you in the next video.